120 light-years away, in the quiet constellation of Leo, the James Webb Space Telescope has detected something strange. Its mirrors, polished to perfection, colder than space itself, captured a faint chemical whisper from an alien world known as K2-18b. And within that whisper, scientists heard a molecule that could change everything we think we know about life in the universe. It's called dimethyl sulfide, or DMS. On Earth, DMS is produced almost entirely by life, tiny marine phytoplankton that bloom across our oceans. When Webb detected a signature resembling DMS in the atmosphere of another planet, the world of astronomy froze. Because if this signal is real, it might be the first time humanity has smelled the breath of alien biology. But what kind of planet could hold such a secret? K2-18b isn't like Earth. It's bigger, 8.6 times our planet's mass, 2.6 times its radius, and wrapped in a dense, hydrogen-rich atmosphere. Scientists call it a Hycean world, a class of planets that could host vast, warm oceans beneath thick skies. It orbits a red dwarf star, smaller and cooler than our Sun, but close enough that liquid water might still exist. It's a world balanced between extremes, a sub-Neptune world with the potential for both fury and calm. When the James Webb Space Telescope turned its golden eyes toward it, it wasn't just taking a picture, it was performing transmission spectroscopy, splitting starlight that passed through the planet's atmosphere into colors like a cosmic fingerprint. Each color tells a story. Some reveal methane, others carbon dioxide, some even water vapor. But this time, there was something more. Something Webb had never seen before. A strange spike in the data, the spectral trace of DMS. On Earth, that molecule is alive. It's released by phytoplankton floating in the oceans, tiny unseen creatures that help regulate our planet's climate. So if Webb truly saw DMS on K2-18b, it would mean one of two things. Either alien chemistry is far more creative than we understand, or we're not alone. But science demands patience. The detection isn't confirmed. It's tentative, a signal near the edge of visibility. Yet even a hint of DMS is enough to ignite imaginations worldwide, because the odds of finding that specific molecule by chance are astronomically low. Now picture the scene Webb's data suggests. You're floating high above the atmosphere of K2-18b. The star below isn't golden, it's deep crimson, bathing everything in soft red light. The clouds glow faintly pink and purple, rippling across a hydrogen sky. Thunder rolls in slow motion, and flashes of lightning illuminate alien storms that stretch for thousands of miles. As you descend, the pressure increases. The air grows heavy, thick, shimmering with strange hues. Beneath the clouds you glimpse an ocean, not blue like Earth's oceans, but dark, reflective, metallic. It stretches endlessly in every direction, swallowing the horizon. This is a global sea, a world of water under a dim sun. The waves rise like mountains, tipped with vapor that glow faintly in the star's red reflection. Deep below there are no continents, no land, only layers of liquid and darkness. And in that darkness, something may be stirring. Tiny forms drift through the depths, transparent, bioluminescent, delicate as glass. They pulse with light, their bodies releasing faint plumes of vapor into the water above. The molecules they exhale could rise through the atmosphere, breaking free into space. Exactly the kind of signature Webb detected. Could these be the alien analogs of Earth's plankton? Or is something else producing those gases? Perhaps chemical reactions deep within hydrothermal vents, far below the Earth floor. Scientists are asking the same question. The confirmed detections, methane and carbon dioxide, point to an active carbon cycle. But the lack of ammonia is puzzling. Normally, in a hydrogen-rich atmosphere, ammonia should be abundant. Its absence suggests that something might be consuming it or transforming it in ways that only biology can. That's the strangeness Webb uncovered, a balance of gases that looks eerily alive. But K2-18b doesn't fit neatly into any category. It's too large to be Earth-like, yet too small to be a gas giant. It might have a deep ocean, or thick clouds hiding an endless abyss. The temperatures there could support life, but life not as we know it. Life that breathes hydrogen, feeds on light filtered through red skies, and builds itself from chemistry we barely understand. If such life exists, it might drift endlessly among the clouds, microscopic organisms suspended in the air, feeding on sunlight and minerals rising from the ocean below. Their chemical breath could be the signal Webb detected, the faint exhalation of an alien ecosystem. It's a haunting idea that right now a living world could be orbiting a small red star, whispering its existence through molecules of gas. But to confirm it, humanity must look again. The Webb telescope will revisit K2-18b, taking deeper, longer observations. Other instruments like ESA's Ariel and the extremely large telescope on Earth will join the search, cross-checking every molecule, every wavelength. If the DMS signal appears again, stronger, clearer, the implications will be staggering. Because if DMS truly exists there, it means life doesn't just happen on Earth. It means nature writes the same biological poetry across galaxies. It means that the ingredients of existence are universal, and that we are not the center of that story. Still, there's a chance this strange chemistry is something else entirely. Maybe it's a new kind of atmospheric reaction or an exotic process that mimics life. Even that possibility is thrilling, because it would show us that the universe still holds secrets our chemistry can't explain. Back on Earth, researchers are already running simulations. Could DMS form through volcanism? Could the planet's atmosphere, under extreme pressure, forge that molecule naturally? So far, no model fits perfectly. The puzzle remains unsolved. And that's the beauty of it. Science thrives in the unknown. The mystery isn't a failure. It's the beginning of understanding. Perhaps one day, future telescopes will capture the shimmer of K2-18b's oceans directly. Maybe they'll see light bending around storms or glimmers of bioluminescence in the night. Maybe one day we'll send probes to Hycean worlds like it, diving into their dark seas to seek out the spark of life itself. For now, all we have is a signal, faint, tentative, but powerful. A whisper across 120 light-years saying, "Look closer. There's something here." So what did Webb truly see on K2-18b? A chemical illusion? A strange atmospheric dance? Or the first breath of life beyond Earth? Whatever the answer, the search has already changed us. We've entered an era where telescopes don't just see planets, they read their air, sense their chemistry, and listen for their pulse. Somewhere out there, Beneath the red sky and an endless ocean, a mystery waits. And whether it's chemistry or consciousness, one truth remains. The universe is alive with possibility. So keep watching the stars, because the next time Webb looks toward K2-18b, we might not just find a planet, we might find a mirror reflecting the story of life itself.